Hi there, everyone. My name is Chelsea Schlautman, and I'm going to be going over Module 1, Written Exam 1 with you. And so the very first set of questions that it is talking to us about, or wanting us to find the answers to, it asks us to draw a graph for each of the following scenarios. So for Part A, it's wanting us to draw a graph that will correlate with the function of the amount of gas in a gas tank when a driver refills the tank on a drive across country. So for that first graph here, you see we have our little graph here, and it shows a line from starting at the y-axis going down, which is showing the driver driving. So for our x-axis here, we're going to have the amount of miles or distance driven. So we're going to drive and drive and drive, and then you're going to see that he needs to stop and refill his tank. And then he stops. The car does not proceed any further, but then the amount of gasoline will go up. And then once he's got his tank full again, he proceeds to continue driving across country. And as he does, you can see the amount of gas in his tank will decrease. Second, we're going to look at an elevator. So this looks like a staircase here, and it is actually going to be an elevator. So as the elevator proceeds moving upwards, it's going to stop at each floor, but it's going to continue to go up. The x-axis shows the distance that the elevator has moved up, and the y-axis shows the height of the elevator. So each floor that it goes up, the graph is moving up on the y-axis. And for the third graph, it's wanting us to graph what it would look like if we were to drop a ball from a specific point. So if we were standing on a table and we dropped a ball, it's going to bounce and bounce. And eventually in time, gravity is going to take control and it's going to make the ball stop bouncing. So here you see the point of where the ball was dropped. It bounces up really high, down, up, down, up, down, up, down, until the gravity, like I said, takes over and it will no longer continue to bounce. So here it shows that the y-axis is where the ball is going to be dropped from, and the x-axis here shows us the distance that the ball will travel before it stops bouncing. And the very last graph that we are going to take a look at here, it looks like a parabola, but what we're doing is it's a flagpole, and it's going to be the shadow that the pole is casting throughout the day with the different heights of the sun. So as the day progresses, the sun continues to move, the shadow will also move. So as you can see right here, the closest to the y-axis, that is the side that the shadow is going to be on early in the morning. And here on the x-axis, as the day progresses, we see that the shadow is going to move. As the sun moves, the shadow also moves. So this one here, the parabola, is going to be the shadow of a flagpole. And for number 2, it is asking us to look at these different functions and figure out what g of f of 0 is, g of f of 1, and so on all the way to 3. So here I have a little chart, an XY table, and it's going to have the numbers plugged in to make it a little bit easier. If you look here at my actual table, my orange line represents the g of f of x function, and the blue line is the f of x function. So if we were to do this using algebra, we would just plug the numbers in on our paper. So we would have the f of x equals 3. So the very first one it gives us is a 0. We would plug that 0 into where our x is. Let me try to find a little pointer here if I can remember how to do that. I do not. Okay, let's see. Okay, so first of all, like I said, we're going to plug that 0 into 3, which would be 3 times 0 is 0. So anytime x is 0, the y will be 0. So we're going to continue that throughout the f of x, which is going to be 3 times 3, and then, 3 times 1, and then 3 times 2, and 3 times 3, and so on. And that's how we get our answers for the f of x function. Then we're going to move on to the g of f of x function, which is x plus 8. So we're going to take the answer we got for x and plug it in and add 8. So we are going to get 8, 11, 14, and 17. And let me see if I can blow that up here. There we go. If we look at the actual graph that we have here for the f of x function, the blue line, we start out at 0, 0, and then we move up to 1, 3. So if you notice, we move over to 1, up to 3. And then we're going to do that throughout. And then for the second one, it is going to be 2, 6. So we move over to the 2, go up 6, and so on. And that's how we graph both of those lines. And then we're going to look at number 3. 3 is asking us to show and explain the slopes of a line segment determined by the given pair of points. So you see here we have 3 different sets of points that it's giving us. For the part A, P is 3, 1, and Q is 5, 5. So what we're going to use here is the formula for a slope. There's 2 different ways we can do it. One, algebraically, like we use the pen and paper and do the math, solve it that way. Or we can plug it into our Excel, which is what I've done here. So you see my XY table here. It shows anytime X is 3, Y will be 3. Anytime X is 5, Y will be 5. So we're going to plot that here on the graph. And as you can see, it shows us the rise over run already. So we see we count 1, 2, 3, 4. We go up 4 over 1, 2. So our rise over run is 4 over 2. Now, the way that I prefer to do it is the old-fashioned method, using the pen paper, doing the math. So what we would do to find that is we would label these X and Y. Let me get my pen here. We're going to label this one X. Sorry, that's a little large. X1 and Y1. And then we have X2. And we have Y2. I apologize about that. I'm not that good at writing on here. Okay, so then what we're going to do is we're going to do the rise over the run. We're going to try to find the slope. So as you see here, we have the formula. We have a triangle Y, which is a change in Y over a change in X. So to find that change, we're going to take Y2, which is 5, and subtract Y1, which is 1. And that, there we go, that is going to give us 4. And then we're going to do the same here, change in X. We're going to do X2 minus X1. So if we look over here, our X2 is 5 and our X1 is 3. We subtract those, it gives us 2. So our rise over run is 4 over 2. I prefer it that way. I like the visual to be able to see the numbers that I'm working with, but it is completely up to you how you would like to do that. Next, we're going to look at another problem similar to that one, and we're going to determine the slope on this one as well. So again, I have it on an XY table for you and graphed out. For this one, we have 5, 8 and 5, negative 8. And as you can see here on my graph, we have the point 5. And then if 5 is 8 here, I'm sorry, let me rephrase that. Let me start over. So for both of these x's, we have a 5. So 5 is going to stay right here. It's going to stay the same. So if we have 5, we can also have 8, and we can also have a negative 8. So since this isn't a defined slope, it's not going in just one direction. It's going to be an undefined slope. So again, I'm going to revert back to doing it the way that I prefer. The math, we have the x1, y1, and we have x2, and we have y2. Okay, so we're going to do the same thing here. We're going to do the change in y over the change in x. We take y2 minus y1, which is negative 8 minus 8, which is going to give us a negative 16. There we go. And then the change in x is x2 minus x1. It's going to be 5 minus 5, which gives us 0. So this here is telling us that this slope is undefined. Anything over that 0 is going to be an undefined slope. And again, the graph, sorry about that, the graph above shows undefined because when we try to graph it, it is not a defined line or defined slope. And then lastly, we're going to look here at number 4. We have, it looks a little confusing with all these numbers here plugged into this chart, but again, Excel does the math for us. It makes it super, super easy. But first, what we're going to do is we're going to pick a few different points to plug into our table, and then we're going to plug those into the equations given, which I have listed here, y equals x to the second power y equals x squared plus 7, and y equals x squared minus 7. So we're just going to take these numbers that we have here for x, which I have -5 through +5, and we're going to plug those in to these equations. So for y equals x squared, if we plug in that -5 and square it, our answer is 25. And we do that all the way through, and that's the answer we'll get here in this first column. The second column, we have y equals x squared plus 7. So we're going to do what we did in the first one, but then we're just going to add 7. So if you would like to, you can just go ahead and add 7 to the answers you've already gotten. And then on the last column, we have x squared minus 7. So we're just going to take those first answers we got from the y equals x squared, and we're going to subtract 7 this time instead of adding it. So that gives us all of our points that we need to plot on our graph. Once we get the graph going, we can start plotting our points. So you can see here we have a parabola for each line. Each line is colored. The first one is orange. It's going to be the y equals x squared, our first set of numbers here. Then the second one is the plus 7. That one's yellow. And then the green line is our x squared minus 7. So let me see if I can zoom in a little bit there. Okay. So you can see they're each graphed, each of those points. If you go through and you look at each point given on our table and plug them in here, that's how we get this answer. So they are all going to be, they're all going to move up and down vertically along the x-axis. And the next problem we're going to look at, let me zoom back out here. Okay, let me get to that problem. I'm sorry about that. Okay, so the problem we have here is y equals -3/4 x plus 5. And what we need to do is we're going to change that -3/4. We're going to take it and get the reciprocal of it, and that's going to give us our m, our slope. Then what we're going to do is we're going to use this formula here, y minus y1 equals m times x minus x1. And we're going to plug in our numbers here, or our numbers, the x and y that we have here. So we're going to have y minus -1 equals 4/3x minus 6. What we're going to do here is we're going to take this 4/3 and we're going to distribute it across. We're going to multiply the 4/3 times x and then the 4/3 times -6. And this is going to be our answer that we get from doing the math there. We have y plus 1 equals 4/3x minus 8. What we're going to do next is get y by itself. And in order to do that, we are going to subtract 1 from both sides. And this will give us our final answer, y equals 4/3x minus 9. And the next problem is going to be one just like we had just done, just a little bit different. It gives us a little bit more on the left side of our equation here. And what we need to do again is get y by itself. So what we're going to do is subtract 9x minus 5 from both sides. And that's going to give us 2y equals -9x minus 5. Now, we still have to continue to get y by itself. So what do you think we're going to have to do next? You're correct. We're going to divide both sides of the equation by 2. And once we do that, it gives us y equals -9/2x minus 5/2. Now we need to find the slope. And to find the slope, we're going to take this -9/2 and we're going to get the reciprocal of that. And we're going to plug all that into that same formula that we used on the last problem. So we're going to take y minus 3. And again, if you don't remember where we got these numbers from, they're from our original equation up here, the s, and then it gives us the points 0, 3. So those points are going to be x, y, and we're going to plug those in to where our y1 and our x1 is. So we have y minus 3 equals 2/9x minus 0. Again, we're going to distribute across. We're going to multiply 2/9 times x and 2/9 times 0, which will give us y minus 3 equals 2/9x minus 0. Again, we need to get y by itself. So to continue on there, we're going to add 3 to both sides, and we have our final answer, y equals 2/9x plus 3. All right, and then our last problem here looks a little confusing from here. What it's asking us to do is to show and explain the equation of the line that is tangent to the circle of radius 9 at points 0, -9. So if you look here, I have it all graphed out where you can actually see the visual of it. So it says there are 2 circles. The first one here I created on my own. The second one I used Excel to show the actual graph so you can see all the points that are labeled to make it a little bit more appealing visually. It says we can see all the points on both graphs of 0, 9, 9, 0, 0, -9 down here, and then -9, 0. And there's an equation that we can do to do this using just algebra, which to some is much easier. Like I said before, it's the way I prefer to do things. So we're going to use a formula, y minus d equals a minus c over d minus b, and then we're going to put in parentheses x minus 0. So let me write that out here for you, make it a lot easier. We're just going to plug it in right here. So we'll have y minus d equals, here we go. There we go. Okay, and then we'll have a minus c over d minus b. And then to the right of that, we have x minus 0. Okay, so now that we can all see that here, this is the formula that we're going to use to find the information we need. So for the very first one, it says that the points given are 0, -9. So we're going to need to plug the 0 and the -9 in. So what we're going to do on this first one, for D, we're going to plug in the -9, and A and C is going to be 0 minus 0, and then we're going to use that 0 and the 9 point again, which is 0 minus the -9. And then we do the x minus 0. So our answer for this one is going to be y equals -9. For the second one, it's the same exact problem, but instead of the points given being 0, -9, the points given are 0, 9. So we're going to just plug it in the exact same way. The center of the circle is at 0, 0. That's where we get our a minus c, and then the points given on the bottom, the d minus b, is going to be the 0 minus 9. So for the last one, we get y equals +9. Alrighty, I hope that gave you a better understanding of Module 1. Thank you so much for your time.